for it.
Again, welcome to everyone joining the RITIS user group quarterly web meeting today. We're very happy that you're here. We have a lot of information to go through. I'm going to very quickly go through some housekeeping items. We're using Zoom webinar today, so you have the option of joining with your audio either through your computer or through your phone. This web meeting is being recorded. If you have questions about the audio or web, please reach out to Esther. You can do so in the chat box or via email. So with Zoom webinar, we have both a Q&A box and a chat box. So today we're going to be using the Q&A to ask questions to the presenters. The chat box will be used for technical issues or to contact coalition staff. So if you accidentally put a question for the presenter into the chat, we may ask you to just put that into the Q&A so that we make sure that it gets answered. To ask questions, you're just going to simply type your question in. Jesse, Denise, and I will keep track of the questions, and either at the end of the presentation or at the end of the meeting or sometime during this meeting, those questions will get answered. And as you know, a Q&A summary is prepared for this meeting, and you'll receive it as a participant of the meeting after the meeting. If you would like to ask a question verbally, you can just raise your hand. That lets us know that someone would like to actually ask a question verbally, and then we can call on you to unmute your line. At this point, I'm going to turn it over to Denise Marco. She is the TSMO Director with the Eastern Transportation Coalition. Denise? I think you're muted. Denise, I think you're muted.
Yes, I am. There we go. Thanks, Joanna. Welcome, everyone. It's nice to see you all here, or at least to look at your names on the screen. Will you move the slide, Joanna? We've got a lot to cover today. So, as always, part of the user group meeting, we do a coalition update. We list some of the recent and then the upcoming meetings that we've had. You can see them on the screen. We've been very active with working with the Waze product and engineering teams on how to improve the Waze app and improve traveler information along the corridor. We're also working with them on how to improve some data feeds to get the data from the states to Waze. So we had 2 workshops, February and March, brought the states together, and we have another follow-up you'll see down below in June. Obviously, we had a PDS Suite PM Performance Measurement Summary Group meeting. That's one of the working groups within RITIS. It was in March. We also had something called a TVR. This is a tolling violation reciprocity group that's dealing with forums on mobile apps. It's an initiative we have within the coalition relative to tolling. We had a CAV workshop that included some freight and some great presentations. All of these can be seen on our webpage. Travel information, we had a virtual summit in April that talked about emerging technologies moving forward, and the British Product Enhancement Working Group meeting. You'll get more of an update later on in this meeting. Moving forward, again, lots going on. Another mobile app vendor forum for tolling. We do have a programmatic strategic planning cross-cutting section where we look at our work plan for the year, look at the TSMO, the freight, and the innovations groups, and see how we can move forward and propose and plan scheduling events. Again, our Waze working group will meet again. We also have a important VPP TDM, which stands for the Vehicle Pro Project, now called the Traffic Data Marketplace. That state meeting is scheduled for June 22nd. It's important to know that the new marketplace RFP was released last week. It's on the street. It's got 6 new data sets. So we'll provide an update at that meeting as well as to other members as we move forward. RITIS, our quarterly group meetings in July, and then as we start to look at the proposals that come in that are due June 30th for the RFP, we'll start working with the states and some of these evaluation meetings. So with that being said, there's quite a lot there, and let's move forward. Go ahead, Joanna. So now, without further ado, let me introduce Jesse Burke. He is one of our user group co-chairs, one of our most valuable assets here when it comes to data tools. He's part of the Delaware Valley Regional Planning Commission, and he's going to take you forward with the rest of the meeting. Jesse, go ahead.
Thanks, Denise. As always, so much going on. So thanks for all those activities. Always a lot of great stuff happening. We have a lot going on today. Great agenda, some really good presentations on using the tools to analyze congestion and also, just travel trends, especially during the pandemic with things changing so much. Michael Pack will give us some updates on new RITIS tools and recent enhancements. We'll also get some updates on the RITIS product enhancement working group that Matt Glasser has really been spearheading. And as usual, too, some PDA suite performance measure group updates. John Allen's been leading that group, and some great templates, for conveying information and analysis from all the various tools. Then at the end, as always, we have an agency input session. So again, if you have questions throughout the presentations, feel free to put those into the Q&A, and we will get to them, if not after the presentation, then at the end. So with that, I think we can move on to the next slide. So let me just introduce the speakers for today. As always, we have Michael Pack, Mr. Pack. Well, he's always with us here. He's the director of the CATT lab at the University of Maryland, where he works to make transportation data more easily accessible and usable by operations planners and researchers. Previously, Michael had worked at the University of Virginia and Oak Ridge National Laboratory. Our two presenters today, first up is going to be Mark Franz. Dr. Mark Franz earned his BA in physics and a BS in astronomy from the University of Florida, and then got his MSCE from West Virginia University and his PhD in civil and environmental engineering from the University of Maryland, with an emphasis on transportation engineering. And currently Mark is the lead transportation analyst at the University of Maryland CATT lab. Also pleased to have with us today my colleague Tom Edinger. Tom is the manager of congestion management programs at DVRPC. Tom has over 20 years of combined experience in transportation planning at DVRPC, and before that at the Tri-County Regional Planning Commission in Harrisburg, Pennsylvania, and also the Lehigh Valley Planning Commission in Allentown, Pennsylvania. Tom obtained his master's degree in city and regional planning at The Ohio State University, and has an American Institute of Certified Planners certified. Sorry. It seems like Tom's been with us for years and years, but actually he's only been at DVRPC for a little over 3 years. It seems like longer time. He's really done a lot with our congestion management process. Recently completed an update, bringing in a lot of information from the RITIS tools. His prior work experience also includes travel demand modeling, air quality conformity, safety, and geographic information systems. And Tom also teaches GIS planning courses locally at Temple University and Moravian College. Next slide, please. As always, we have just so many participants, and thanks to everyone who's tuning in today. I see we're already up to well over 80 attendees, really from all around the country. We've expanded well beyond the East Coast here into the middle of the country, into the West. So just glad to have everyone here today. And with that, I think we can get into the presentations, and our first presenter is going to be Mark Franz. So Mark, I'll turn it over to you.
Thanks, Jesse. Can everybody hear me okay?
Yep, you sound good.
Okay, next slide, please. So today I'll be going over the recent updates for the transportation disruption and disaster statistics, TDADS. Essentially, it's the pie charts for the causes of congestion. In my presentation today, I'll talk about or remind you of the objectives of the project, what we accomplished in phase 1. We were also found some similar studies that were out there by the states of Colorado and Pennsylvania. I'll quickly summarize them to highlight the similarities and differences between what we're trying to do and what was done in those states. And then I'll get into the update of the phase 2 work, where we're working on building the full national pie charts with some additional features. Next slide, please. So just a quick background then on how this project came to be. So the causes of congestion pie chart is a pretty famous study that was done by Cambridge Systematic and the Texas Transportation Institute on behalf of FHWA back in 2005. So it's 15 years old now, and it was a national statistic. A lot of this was largely modeled, even though it was really great groundbreaking work at the time. Obviously, the technologies and data available to do this is allowing our team to do this without having to do any modeling. So we're only using the real world data to kind of update this pie chart and provide some better resolution, both temporally and spatially, as I'll talk about as we go through the slides. Next slide, please. So the goals of this project, and it's a multi-phase project. So in the first year, we developed the methodology to kind of use the real world data to identify and quantify congestion and then assign it to a specific cause. So we've been working with a steering committee that's been giving us some feedback and guidance on our methodology, and also on the interface design for the tool that's ultimately being used to present this information. In this next round, we're trying to do the entire national highway system and segregate it by state to and by county, so that people can drill down and get more detailed and specific information. And we're going to be doing this for the entire calendar year of 2019 and ingesting this into a tool that'll look similar to what we did for the initial version with some enhancements, which I'll talk about. Next slide, please. So in phase one, I started to talk about this already, but the identification of when and where there is congestion and quantifying that, and then getting into the assessment of the data coming from multiple different sources. So things like Waze data, the National Oceanic and Atmospheric Administration provided radar weather that we were able to conflate to the roadmap. So we came up with a process to do that. We also linked traffic signals to probe data, which is something that, for the first time we directly did that so that we can infer the delay caused by signalized intersections. We also were able to tease out some information about when there's multiple causes that cause congestion, so work zones plus weather, things like that. So we came up with some methods on how to do that. We automated some of this steps, so this would go on in the background to create the process. And this next phase, we're actually trying to make it even more automated. And then we also developed the visualizations in the interface so that people can go in and interact dynamically with the data that we have to investigate the causes of congestion in there, whether it's at the national, state level. And you can also do the breakdown by month. And we'll get down to the county level even in our next phase. Next slide, please. So when we look at what we did in year one and compared it to the study done back in 2004 for the national level, this is what it looks like. So in phase one, we applied our methodology and ingested the pie charts into our RITIS tool. And we did that for the states of Colorado and Maryland. Those were the two states that we decided to do, as we had the 1 minute probe data that was needed for this, for the initial phase. We look at it side by side, and it's not a direct apples to apples comparison. Obviously, we had some slightly different categories that was used in the national chart back in 2004. And we also added a few additional categories that weren't in the original pie chart, including the multi-factor, as well as another sort of catch-all category for unclassified when we're able to detect some delay or congestion, but we can't definitively determine what the exact cause was. So we see the potential to change how we look at congestion. And then also, because there's different categories, it changes the distribution and the contribution of the various causes versus what was done in 2004. Next slide, please. So for this next phase of TDADS, there's 5 general steps that we're going through to update the tool to provide more data and finer resolution. So the first step is getting the data, which we decided to get from Nrx, the 1 minute probe data. We made that decision because the 1 minute data is what works with our methodology to identify and quantify the congestion derived from our bottleneck ranking tool algorithm. We also wanted to implement geographic and temporal improvements. So this is going to allow people to drill down not just to the state level, but also to the individual counties. Again, this was a recommendation that we got from our steering committee about getting down even lower than the state to make more definitive decisions. And this can also be tied to looking at the causes of congestion in urban and rural areas. If you have a general sense, if a given county is within one of those two general categories, then you can start to do that with this tool that we'll be developing. Then we also are going to start thinking about the next steps beyond phase 2, looking at a deep dive analytics that'll, our vision is to ultimately implement it into a PDA style tool where the users can go in and do a custom road and date range selection and generate the pie chart for that selection. It could be an individual road, it could be a state, a county, whatever, for a month, for a year, whatever they wanted to do, specific dates. And then also, we want to develop the tool and have national webinars to get the word out that this data is available. And we're hoping that we can help to also, I won't say standardize, but come up with a common methodology in case other researchers and states want to conduct similar studies on their own. And of course, the last step is just to launch the tool so that people can start investigating that data and interacting with the tool on their own. Next slide, please. So as I mentioned, there's been some other studies that other states have been pursuing, and I'm sure that there's more than what are on this slide, but we were asked by FHWA and the Bureau of Transportation Statistics to take a look at what those differences were. So I won't go into too much detail here because on the next slide, I kind of summarize everything, but the main takeaway is, Colorado did a study, but it was more for travel time reliability than just congestion. And they did it, using their own state data. And they only had a short list of causes that they looked at. Pennsylvania did something, I think, a little bit more similar to what we're trying to do. Within their state, they looked at their core network, and they used their own, state verified data when they could, and fell back to using crowdsourced data like Waze when it didn't work out. And what they did is they did their identification based on travel time surrogates. They looked at queue length and speed drop, and they didn't look at the volume in Pennsylvania. We are trying to integrate the volume, and we are integrating the volume into ours, so that's one difference. And then, in each of these studies, they have their own list of categories that they included in the causes of congestion. One thing that's different from ours versus the other studies is we have the multi-factor cause, and we're also looking at traffic signals within our study. Next slide, please. In any case, the main takeaway of highlighting other studies are going on, and there's probably more, as I mentioned. There's a sense of urgency, I think, for the industry to set a standard just to make sure that if and when others want to do similar studies, that the core methodology of identifying, the congestion should be fairly consistent. So I think that it is important for us to, as a team, take a lead on helping to set that standard for others to follow. And we don't want too much deviation in that when other agencies do it on their own. And we think that it could be an issue if other methods are put out there and lead to misleading results. So we're hoping that our project will help address all of these things and help for establishing a more consistent method to identify and relate the causes of congestion to specific categories. Next slide, please. So within the phase 2, there's 10 tasks that are in our statement of work today. I'm going to highlight just 4 of them. I'll quickly talk about the steering committee progress and their role as more of a reminder of who's on the committee and what their role is. I'll give an update on our procurement of the Nrx data, how we're working on a code to more efficiently process the disruption statistics. And then I'll give a brief preview of some of the interface designs that illustrate the implementation of the geographic and temporal improvements in the tool that will be launched when the project is complete. Next slide, please. So the steering committee, many are on the call today. The role that they had in phase 1 is very similar to the role that they'll have in this project. So this is the first time that many people are seeing the work on phase 2 that are on the committee this time around. So they're really here to steer our team to make sure that our methodology is sound, which really isn't changing from phase 1, but also to make sure that the end result is what they're expecting and that the interface and design of that meets their needs. And then also to provide some feedback on how we can take the next steps of, continue to drill down and improve this tool with, from the CATT lab perspective, we would like to ultimately get down to developing a PDA style tool so that people can do custom road and date selection. So that's sort of how the steering committee is working with us and giving us feedback on end user perspectives for the research and end products. Next slide, please. So this map sort of illustrates the diversity that we have in the steering committee. So we have folks from all over the United States and representation from different levels of agencies. So in total, there's 47 organizations that are represented on the steering committee. 35 are from the state DOTs, 9 MPOs, 2 universities, and 1 national association, with that being AASHTO, that's helping provide some feedback on the development of this tool. Next slide, please. So task 3 is we'll start to get into some of the more technical development for this project, and this is the procurement of the Nrx data. So it's not just signing a contract and we get the data right away. So we obviously didn't have all of the 1-minute data for the entire national highway system because not all states are RITIS or PDA members. So we had to get the data from Nrx, and the way that Nrx stores the data is just a sort of dump of data, but we want to kind of organize it into different bins by state and by county so that when we process it, it can run a little bit quicker. So as that's going on and we get the data, we'll start to process it, and it's kind of going on in parallel as we get the data. So we're still getting some of that data. We're almost done getting all of that from them now, and we're starting on processing some of that data. And of course, we're working on automating more of the process so that it's less labor intensive for us to process this data, and we're comparing those automated results to what we did last year, just to make sure that the results are consistent, and kind of double checking that. And then ultimately, we'll continue to do that for every state and every county for all of 2019, which will ultimately be the database that's used to populate the online tool that will be shared with you all toward the end of the project. Next slide, please. So talking about this is probably the most comprehensive technical task in the whole project, is the actual processing of the data. So in phase 1, as I mentioned, we came up with a methodology and got some initial results from Maryland and Colorado. So it was identify, quantify congestion, and then categorize what was the underlying cause. So in this phase, we want to be able to do that not just for those 2 states, but for the whole national highway system, and segregate that by counties and by states, as well as by month. So we're trying to automate that process a little bit more, which it not only helps in this phase of the project, but any future phases where we continue to process the data. So it takes some of the manual work out of computing the statistics that we need for these types of analyses. And just to give you a perspective on the difference in the data size between phase 1 and phase 2. So in phase 1, again, we had Maryland and Colorado together. They were about 13,000 traffic message channel road segments from the probe data, with about 4.6 million Waze events, and that's just one category of our congestion. But when we look at that on a national level, which is what we're doing in phase 2, we're almost at 370,000 TMCs and over 100 million Waze events that we have to match those congestions. We look at each bottleneck occurrence one at a time for an entire year. So you can imagine the processing time it takes to do something like this. Next slide, please. So then just to give you all a sample of some of the interface designs, improvements that are going to enable us to present the information in a more refined and better resolution, both temporally and spatially. We're going to allow users to filter the data this time around by year, by an individual month within the year. I guess this is just for 2019 for this phase of the project, or you can do a continuous range of months. So if you wanted to look at quarter 1 of 2019 or quarter 2, whatever that custom range is that you want to look at, we're going to be able to support that in the tool. We're going to allow people to, again, look at the nation, the state, and the county. And we have a way of locking in the nation and the state and the county so that you can look at all three of them side by side without having to scroll and make things all on one screen. So that'll show you the contribution of the county to the state, the contribution of delay of the county to the state, and then of the state to the nation. So kind of a hierarchical buildup of those, and I'll show that in the next slides. I've mentioned the nationwide, state, and counties for the geographic improvements. And then there's also some more sophisticated filtering to find the state or the county that you might be interested in focusing in on. Next slide, please. So we're kind of generalizing these improvements as temporal controls, visual style controls, geographic, and then sorting controls across the top banner. So again, the temporal controls allows you to drill down to specific dates of time. The visualization style controls is essentially allowing the user to switch between two different displays of the data. We have the traditional pie chart, which I think most people are familiar with, but then we also have the option to look at bar charts. Then we look at the geographic controls, so you can look again at states or to drill down into specific counties within given states. And then you can do the sorting on the end there where the filter icon is at to do a text search or to scroll through a list of alphabetized counties or states. Next slide, please. So some additional enhancements that we're including in the interface this phase is providing not only the overall user delay cost and vehicle hours of delay, but as I mentioned before, the roll up of the states to the national and the counties to the state. So you can see these additional icons show or labels next to the UDC for the state saying 0.9% of the US. So again, this is not real data. This is just a mock-up of simulated data. So this would say that almost 1% of the total US delay is coming from the state of Arizona. And in a similar fashion, you can look at the county level. So Apache County is nearly 7% of the total delay in the state of Arizona. So that's another feature that we're adding to the interface this time around. Next slide, please. So just to show you more details about the sorting and filtering. So you can go in and select any number of counties or states that you want to see within their parent geography. So if you want to see all of them, it'll create a scroll bar so that you can scroll through in alphabetical order. Or if you have a subset, you go in and just click the checkbox on the ones that you want to see, and they'll be sorted in the same way alphabetically so that you can see them. But while you do this, as you mentioned on the left here, one thing not to overlook, and it's not really illustrated on the mock-up, is that the Arizona state pie chart is locked in, and to the left of that would be the national, so that you can see the county, the state, and the national all side by side without having to take individual screenshots and things like that if you want to include this in a report. Next slide, please. We also, as I mentioned, in addition to just the full year and individual month breakdown, you can do custom ranges. So you can go in and select, as long as it's a continuous range of months, you can select that. And then as we had in the initial design, when you click on any slices of the pie or bars in the bar chart, if that's the case, it'll pop up the bar graph that's below each of the charts showing the breakdown or the contribution. In this case, the hours of delay coming from recurrent congestion is what's being shown. But when you click on it once on the national level, it'll automatically populate them for the state and county level as well. So it automates that process, and you can see if that pattern of temporal trend for a particular category is consistent across the different geographies that you might be analyzing. Next slide, please. So what are the next steps then? So we're going through this process of iteratively going through the getting the data from Nrx, and as we get it, we're organizing it, and then we start processing it. So those are kind of going on in parallel. All along while we're doing this, we're generating some initial results that we're going to share with the team. Hopefully at our next committee meeting, we'll have that ready to share with you. And we continue to get the data from Nrx and processing. And then at the end of this, all of the data that we process will ultimately be uploaded into the online interface that I just showed you the designs for, so that you all can start interacting with that data and exploring it. Next slide, please. I think that's the end for me. Happy to take any questions or comments. I don't know if we have time to do it orally, but I'll keep an eye on the chat box as they come in. Thank you.
Thanks, Mark. Great presentation and lots of questions coming in through the chat box. How are we doing on time, Joanna? Do we want to touch on some of the questions, or it looks like Michael's been able to answer a lot of them in the chat box?
Yeah, I think Mark is Michael a drink or something. Michael's been working hard answering a lot of questions in there. So I think we're going to keep moving on, because that was a good and thorough presentation, Mark. Again, if you want to go and add to any of any of Michael's responses, you can just go right in there to the answered questions and add anything you'd like. But Jesse, I think it's best if we move on.
Joanna and Jesse, this is Denise. Before you move on, one comment is that if there's anybody that's attending that wants to be involved with the steering committee, they can either send Mark or myself an email. We'll be glad to include you in those meetings. Okay. Thank you.
Thanks, and thanks everyone for all the great questions. I think it shows, just how interesting this topic is. But I guess with that, let's move on to the next presentation.
Okay, yep. I'm going to try to share my screen here. I think it's shared. Can you see it, Jesse?
Yes, we can see it.
Okay,
Yep,
thank you.
there it is. Perfect.
All right, great. Yeah, so my name's Tom, manager of the congestion management programs at DVRPC. As you can see, the topic here is COVID-19 impacts on travel trends using the RITIS-PDA suite, using Pm3 travel time reliability, congestion, and other performance measures. I'll probably go over the other performance measures first, and then loop back to the Pm3 travel time reliability. For some of you that aren't familiar with the area, the DVRPC region includes 9 counties. 5 counties in Pennsylvania, 4 counties in New Jersey. So you have Bucks, Montgomery, Chester, Delaware, and Philadelphia in Pennsylvania, and then Mercer, Burlington, Camden, Gloucester counties in New Jersey. Kind of the darker black colors on the mapping to show some of the major roads in the area, and kind of the lighter areas are kind of jurisdictional boundaries. And then the blue is just passenger rail line area. So it's pretty extensive commuter passenger rail lines within the region. And you can see up above to the right, just some other information there. For example, population estimate for the region is about 5.75 million. So what do we mean by travel trends? So we're using the vehicle probe data from the suite to understand or analyze travel time index, planning time index, speeds, the Pm3 travel time reliability and congestion measures, and essentially compare that month over month or year over year. So why evaluate COVID-19 impacts on travel trends? So certainly want to focus investments where they're most needed. As we know, there's been certainly a lot of reduced traffic in 2020, later 2020 and 21, now even too. And so we want to understand for scope of some projects where we have potentially to mitigate congestion, maybe we want to change the scope of that or table a project and look at other alternatives. So for example, areas where we may have capacity adding as a strategy, or we want to implement, maybe we'll do variable speed limits, for example. So we kind of want to understand, look at these trends. Some of the considerations we think about are certainly where are these locations on our regional system. Also, certainly people that took transit to work and now are required to go back to the office. Instead of taking transit because of health concerns, they may want to drive, which could in some locations. Alternatively, right, people working remotely or close to remotely from home will potentially maybe cause more trips during non-peak hours on certain roadways. So how do we manage that on our traffic system? And certainly there's, with reduced speeds, there could be higher reduce congestion, there could be higher speeds on some roadways. And so how do we consider that in our mitigation strategy? For example, traffic calming might be a strategy, or just frankly enforcement. So we want to understand kind of where congestion is or isn't happening in higher speeds and not higher speeds. So how do we do that for the DVRPC region? Because it's a very large area, we want to look at information by corridor. So as part of the CMP congestion management program, we broke down the area into 276 corridors. And actually, if you multiply that times 2 for direction, over 550 corridors. So in blue here are these corridors. Some are longer, some are shorter, depending on interchanges on limited access roadways, intersections on arterials, and really where there's breaks between urban and regional areas. So here's just kind of an overview of steps as far as this travel trend analysis. Step 1 is want to use the PDA suite to create TMC sets so that we can analyze these corridors. So that's a big process. Then the second and third steps are to download this data, either individually one TMC set at a time or more automatically through the RITIS API. Step 4 is essentially taking this data and analyzing it, summarizing it into spreadsheets to look at performance measures within for each corridor. And then we want to take all these corridors and kind of put them into kind of a dashboard and do some comparative analysis with that through some looking at this congestion reliability and speeds information. And then from that, we want to identify really major changes in congestion. And then from that, step 7 would be to create some performance reports. Actually, some provided by RITIS and the CATT lab. So just to go over these steps pretty briefly here, this is a PDA suite widget to create TMC segment set. So a couple of steps here, you just select your data source. We happen to use the TMC Nrx Data. You want to select by road, kind of narrow that down within a county region. This would be Montgomery County. You would type in the road name and you get a selected set of intersections for that particular road. In this case, we want the first one. So this would show, for example, I-76 from 276 down to US 1. Now, in some instances, we may want to drill down a little bit further so we can just look at part of that corridor. So we may want to select the direction. So in this case, we want just eastbound, and we want to look from into an intersection. From intersection, we'll change to this Matsonford Road. We'll keep the to intersection. So we're filtering that down. A lot of times this will serve the purpose for the corridor to match the CMP corridors, but there are instances where we may modify some of the segments on that TMC segment set. There could be multiple segments within between intersections. So you could hover your mouse over a segment and then remove that, or alternatively, you could add a segment. You could use this map tab here, and there's some drawing tools, draw kind of a polygon area where you want to add a segment to the TMC set and add that. So that's what this is being shown here in green. And then after you do that, you want to save your segment set. You provide a name for it. Again, you want to be kind of specific on the name. When you have a lot of segment sets, like over 500, you want to be able to find it fairly quickly, or if you're other tasks you're working on, so that maybe are different names, you want to try to provide keywords. So once you create these segment sets, now there's certainly that's a lot of segment sets to create, but we want to do that a little bit more automatically. I'll get to that in a bit. But then to retrieve that segment set, you go into a PDA widget. This happens to be the massive data downloader widget. Click on the Save tab. Then you type in your filter by text. And that's the key word, making sure that whatever name you type in, you can get access to that segment set quickly. And you'll get a display here, and then you'll say add selected segments, right? So then this is the particular corridor that was created from that. And so then you can perform maybe some analysis within the PDA suite using different widgets. In this case, since we have a lot of corridors, I actually want to download it to perform more custom analysis. So develop a query here to look at data, for example, in this case, all of February 2021, select by days of week, just the weekdays, the hours of the day, the particular measures that I want to download, and with the Nrx Data, unit of measure, averaging or not, and then you provide a title name so that basically you can recognize that data when you download it. It basically becomes an email, so you can then download that as a zip file. So again, when you have a lot of different corridors, this can be a little bit time consuming to do. So we want to try to find an alternative way to do this a little bit more automatically. So we're using the RITIS API to download this data. And really there's three main steps to this process. It's kind of a Python script with some JSON queries embedded within it. So there's a submit request that has basically your travel time query in here. And then you wait for that request to be completed. And when the job status is good, then you get the results of that data, and it's downloaded as a zip file. And so, essentially this is done automatically in the background. And this is just an example of a snippet of some of the criteria for the travel time query. Not like what I just showed earlier using the widget, the fields you want to download, the measures, the date range, the days of week, the start and end times, and the TMC segment list, which would be different for each segment set. So this is kind of all done in the background automatically to populate these. And then essentially all that data is downloaded. Once that data is downloaded, then we want to use some other processing to update that into spreadsheets so that are summarized by the different performance measures so we can analyze those. So basically read the zip files, average the data by time of day, week and month, and update the spreadsheets. And then from that, it's each tab in the spreadsheet has a particular a corridor, and then we can create line charts from that to kind of understand by hours of the day which areas are more congested. And then the sixth step here is combine all this into one kind of dashboard spreadsheet to just quickly understand which areas are performing better than others, and then from that do some comparative analysis. So this is just an example here of each corridor in a Microsoft Excel spreadsheet tab. This happens to be 19 eastbound. And basically in the horizontal axis here is each week of the month. And then the vertical is each hour of the day. And you have basically, in this case, the travel time index averaged. So for example, 1.64, the TTI for the AM peak period is here. And for the PM peak, it's 2.63. So essentially, that helps in understanding what's going on in that particular corridor in that direction. Moving on here, then we can do that for the next year, February, let's say 2021, and then compare year over year. So for example, we can see, there's more congestion here in the PM peak in 2020 versus 2021, right? And then also, for example, notice here, there's a little bit more congestion during the non-peak in 2021 compared to 20. So obviously there's February 2020 is basically during COVID, February 20 is really pre-COVID. So you can see that typically there's going to be less congestion in 2021 for the peak, and then a little bit more during the non-peak. So, so we take this data and we want to kind of look at, again, all kind of a dashboard to do comparative analysis. So we list the corridor name, the county, limited access or not, the different performance measures, just kind of one at a time, average for each week of the month, average by the month, and just looking in this case over two different peak periods, either AM 7 to 8 AM or the PM 5 to 6. We want to look at the change or delta year over year, the percent change year over year, and then the ranking of the delta, the percent change, and the for example, the 2020 or 2021 TTI. So, and the one value would be more congestion or for example, higher speeds. So this is an example of the dashboard listing essentially the corridor name, the county, the 2020 peak hour TTI by week, the 2021 peak hour, and then these are the summary and statistics and rankings. And you can see here the legend at the bottom left is basically the travel time index. So essentially we consider anything 1.5 over to be severely congested for TTI. So basically anything in the reds, orange, or dark red or brown would be congested. Certainly 2.5 would be very, very congested. So if we just highlight this, we can look at really quickly at some corridors that are in 2020, they're pretty congested and not so much in 2021, right? And there's even instances where it's congestion both in 2020 and 21. We can drill down even further and look at specific corridors. For example, here on A, these are travel time decreases. It goes, you might say here from high to low, 2.07 to 1.05, okay? And it's ranked 10th highest in 2020 and 254th in 2021. So it went down significantly in congestion. So you kind of go through this process of looking at these corridors. The other way to do it is to visualize some of this information. So this is the same data, the PM peak hour travel time index, February 2020. And I just highlighted some areas that were the most congested, which is 1.50 or greater in brown. And if you compare that to 2021, really they're not as congested, right? Because traffic patterns is a result of COVID-19. So this is another kind of analysis that shows that. There's just some areas here showing that number of corridors in the highest class break decreased from 75 to 25. It just goes to show how much congestion decreased. And this is showing basically in areas where there really wasn't a change in congestion from 20 to 21. And certainly if there's projects to manage congestion, we want to certainly make sure those are still there and to implement those as possible. So we take all this information and we really want to identify the top corridors that experience major changes in performance. So we have just a summary sheet listing some of the information as part of the analysis. And we want to identify the top 10 corridors during the AM PM peak periods with the highest TTI in February, for example, 2021. This is showing for the AM PM peak period for the PA portion of the DVRPC region and the New Jersey portion. We also want to show the top 10 corridors with the greatest change or the greatest percent change decrease in TTI year over year. So this shows for the AM and PM peak periods for Pennsylvania. So the areas in blue are highlighted just to note that they exist both in the greatest change decrease in TTI and the greatest percent change decrease. And then also we do the same for the New Jersey portion of the region. So there's a lot of information here. And then we would want to look at both planning time index and speeds as well, having the same kind of analysis, which we've done. Then we want to drill down a little bit further and say if we're one of these particular top 10 corridors, let's say in Pennsylvania during the PM peak, we want to understand a little bit more about what's going on in that corridor. So this highlights one we're going to look at. Develop these corridor yearly performance reports thanks to the CATT lab and the templates that were provided. And basically the first page here to the left just shows the general location of the corridor. The page on the right is just a little bit more detail showing alternative roadways as part of integrated corridor management. And also an overview map of where the location is relative to Philadelphia, the city here. So the corridor is northwest. And then maybe a little bit about the corridor, like there's 130,000 vehicles per day, 4 times more than what it's built for. So there's certainly a lot of congestion on that. And then we use the different PDA suite performance, PDA suite widget tools to create different analyses. So for example, the performance chart tool is shown here at the top left to look at corridor travel times. The congestion scan tool is shown at the bottom left here. So just for example, on the west, usually on the left is the eastbound, on the right is the westbound. So for example, westbound during the AM peak, there's more congestion than the eastbound AM peak. On the eastbound, look at the congestion scan tool. The most congestion is during the PM peak eastbound from Matson Ford Road to Hollow Road. So it actually gives you the road name so you can understand the extent of that. To the right is some other analysis using the performance summaries tool. So in this, it basically shows travel times and planning times by month. And you can kind of look at it real generally and notice that travel times go down significantly and then kind of bottom out in April, not surprising. It's part of COVID-19 trends. And then travel times kind of go up a little bit. So that's a general trend. And the bottom right here is look at the same information, but looking at it as a percent change year over year with January as a baseline. So for example, during the eastbound PM peak, you can see it goes down a percent below January baseline and never gets farther up than about 40% compared to January baseline versus westbound. It's about at pre-COVID conditions, about almost 0%. So you can look at those kind of trends. And then finally, you can look also at comparison with previous years. So how is congestion changing over a 4-year period comparing 2017 to 20? And you can see this is actually by by day of the week. So typically the first 3 years, higher travel times, and that 4th year, that 4th candlestick here, you can see there's less travel time. And that's pretty consistent throughout these graphs. This chart here actually shows incrementally every year is a little bit more travel time and more unreliability. So that's kind of one part of the analysis. The other part I wanted to show really quickly is using the PDA suite MAP21 widget to analyze PM3 measures. So looking at travel time reliability, truck travel time reliability, peak hour, excessive delay. I'm just going to look at the non-interstate travel time reliability and PHED. So within the widget, I just select on the area, the geography you're interested in this case, the non-interstate NHS, 2019. I want to map this information out so I can download it and potentially map it out, and then add a widget name and add that. So this is the map within the PDA suite widget. What's nice about this is it shows you reliability by direction of the roadway. Areas in red are not as reliable as areas in green. And as you zoom in, you can see more segments as part of that. But in this case, you want to download it. What reliability by county is part of this analysis. So we download the data and update into Excel and really quickly show for Pennsylvania, the percent travel time reliability just for non-interstate. So you can see on the horizontal axis, the 5 counties, the PA portion of the DVRPC region, and then statewide. And we break it down into looking at 2019, 2020. And the vertical axis to the left is the percent reliable. So the higher percent, more reliable. And then basically on the right is the number of miles of roadway. So quickly seeing Chester County, for example, is most reliable in 2021. The least reliable, for example, here would be Philadelphia at 83%. And notice statewide, it's 94% reliability, much way above, pretty far above the PA 4-year target of 87.4%. So you can see across the board more reliability. Also, just looking at the change in miles, so the number of miles went down, which is good. So the more reliable roadways. So in this case, just looking at the 5 counties on the horizontal axis, again comparing 2019 and 20. Philadelphia had the most miles of unreliable roadways, 85. So there's some work to do there. Montgomery County, for example, had the most decrease year over year, 60%, 105 down to 42. And then certainly you can map that out to look at 2019 level of travel time reliability, and then compare that to 2020. You can see that it goes down quite a bit. You can even look at the areas where it's not reliable in both 19 and 20. Certainly these are areas we want to manage congestion. And I threw in this slide just quick to do a change, look at the change year over year. So the dark green roads essentially just represent ones that are just as more reliable in 2020 than in 2019, or about 69% of all the roadway miles. Finally, the peak hour excessive delay measure. This is for the urbanized area in Philadelphia. And I just wanted to show this map. It's 4 states, Pennsylvania, New Jersey, Delaware, Maryland, 15 counties, and over 4,000 miles. Some counties are hardly represented. For example, Hunterdon County, New Jersey, Atlantic County, New Jersey, and then other areas like Philadelphia are totally covered by the urbanized area, and Delaware pretty much as well too. So when you look at the by county, get an appreciation for why some areas are more than others. So the horizontal axis here is all the counties, and we look at both interstate in blue and non-interstate in red. And the vertical axis on the left is the annual hours of PHED, and then the number of miles on the right axis. So you can see that there's a lot. Philadelphia has the most interstate, non-interstate PHED. Interestingly enough, Newcastle County in Delaware is not in our region, but it's fourth highest in non-interstate delay. And you can see it goes down a lot in 2020, 19, 20 across the board. So it just shows you the impact of COVID on congestion. And this just shows the percent change year over year. For example, Montgomery County had the most percent decrease, 72% for interstate, and Chester County had the 57% decrease Chester County had the most decrease for for interstate, and Chester County the most decrease for non-interstate, 57%. And this is just showing a map. So this is 2019. Certainly areas in brown and red are the most delay, and then in 2020, less. So just quick takeaways, certainly access to the RITIS-PDA suite, vehicle probe data, and the tools combined provides the great capabilities to understand these travel trends and just to perform these analyses. Automating these processes for a big region like the DVRPC to look at every corridor was really crucial. So it provided efficiencies and really saved some time downloading maybe these one at a time, which is kind of error prone as well. Performance reports were very useful for basically telling a quick story and getting this data kind of compact in one area and serving as input into future work. Moving forward, we want to look at truck travel time, reliability, freight movement. We want to look at these Pm3 measures, which are really, some of them really small segments. We want to aggregate those a little bit by a corridor so that we can look at strategies. So that's something we want to do as well. Better incorporate what Franz was talking about, these traffic events into our analysis by corridor. We've done that already, but we want to do that if we can more automatically. And then really just continue and develop these performance reports and build on those with multimodal performance measures, transit, look at the traffic events, and really just some mitigation strategies that we want to use as part of that. So that's all I have. Any questions or comments? Maybe better to save that for the end.
Thanks, Tom. That's really great. So much detail and really using so many different aspects of the tools and also the performance templates, which is great to display all this information. So I think there was a couple of technical questions for you in the Q&A pod there. So I think maybe we'll let you answer those in there while Michael walks us through the new RITIS tools and recent enhancements.
Sure.
That's good. Thanks, Tom.
All right, next slide, please. I'm going to give an update on things we've updated or fixed since the last meeting we had. First is the radio scanners that are in RITIS. We had to take them down for a period of time while we worked out some technical and legal issues, but those have all been solved. And so now radio scanners are live again. This is so you can listen to like police, fire, and rescue. Next slide, please. We had some issues with exports when you're exporting data either from the event query tool about when crashes happen, or in the detector analytics for all your point sensors, where the date and time range wasn't ISO 8601 compliant. It wasn't in the right format. So it made it difficult for some users to work with it in Excel. That's now been fixed. Next. COVID-19 impact analysis platform. Next slide, please. So here we've done quite a few updates. We've now added these national level trend charts in the upper right-hand corner of the platform. So if you click any metric in the national statistics table in the top right corner, then you'll see a trend chart that goes back to January 1st, 2019 and show you what's been happening nationally. You can still get to the state or the county level charts by clicking on individual state or county, but those national stats are there now. Next. And we've also now providing percent of out of county trips and percent of out of state trip metrics. Those are two new metrics that you can click on that are there that weren't there before. Next. And then certain public health metrics that have kind of been out of date for a while are now updated more frequently based on some new sources that we've found. That includes things like percent hospital bed utilization from Esri and some Institute for Health Metrics evaluation as well. Next. And then the SARA index, Society and Economic Reopening Assessment tool, that has had some things updated in it and impacts the new CDC guidelines for when states should be opening. So make sure you go and check that out. All that's been updated. Next. Next. Within the probe data analytics directly, the default name for the PHED widgets now include the selected time of day information that you've chosen when you're producing the metrics. That's up in the header, so you won't be confused. And then the road segments in the temporal comparison map for PHED now use a new default color scheme for better visual contrast. That's in the brand new TCM tool that the Michigan Department of Transportation funded last year. Next. We also have added custom mouse cursors when you put your mouse over the different color ranges. And make it clear that the color bands to be clicked will allow you to customize the colors in the visualization, so you can change them to whatever you want them to be. Next. The My History link in the top right corner of each page will now open in a new browser tab by default to keep your work tab safe, which has been a frustrating thing for me. Next. This is more of a notice than anything else, but the 2020 Pm3 reports that are due to Federal Highway on June 15th are now complete and ready for evaluation by your agency, and you can submit them up to the Pm3 portal. If you're responsible for this, you've probably already been doing this, and you've been sending our support team a ton of questions anyway. As usual, if you have any questions about any of the errors or warnings that you get when you submit these, just reach out to our support team and they'll get back to you pretty quickly. Next. The dashboard's ranked bottleneck comparison widget allows you now to choose how many months the widget should look back, with a maximum of 12 months. Before it was something different, much smaller. So now you can look at a whole year's worth of data. Next. That's not the bottleneck ranking tool. That's the bottleneck ranking dashboard widget. And the performance charts, now you can have multiple tooltips and lock those into the charts for if you're doing some sort of a screenshot that you're gonna dump the visual into a PowerPoint deck, or if you just need to be able to compare things better, you can do these multiple tooltips locked, which is nice. Next. And then there's numerous bug fixes that we've made. And if you want to see a complete list of everything that's been done in the PDA suite, there's a link down here at the bottom, pda.ritis.org/suite/updates. And that includes a full list of every single bug that's been dealt with and resolved. Next. Now within the trip analytics tool, which fewer of you have access to, but there's a new feature that lets you see a breakdown of origins and destinations for a selected area. So you're able to essentially click on a particular a number that pops up. And when you click on that number, it then is going to draw a series of lines and create markers for where all of those origins or destinations were. Next. And we've redesigned our maps for the trips analytics tool as well. The new maps de-emphasize the roads and make it easier to recognize the displayed routes and query results. So you're not kind of competing visually there. Next. In the route analysis tool, a new button lets you download the table that you're seeing as a CSV file. And this file then contains all the values that are in the route summary table, so you can do your own offline analysis. Next. And we also have this really cool thing where you can now view the full extent of your data set. So let's say you're the state of Maryland, you've purchased a trip data set, and you want to see, where did trips originate from, or where were people going to within the data set that you purchased. And you click a little link, and it will then show you any place where a trip came from or went to before you start to do your analysis. So you've got some sense of the geography that you're going to be coping with here in your results. Next slide. And then you can click another button within this particular visualization that then shows you, for the geography that you've got data for. Here's Massachusetts as an example. It then shows you all of the crossing points for that geography. So for the state of Massachusetts, here's every single place that a trip can come into or go out of for that particular state. So this is all available within the Trips Analytics toolset now. Next. I want to remind everyone that there's a big maintenance window coming up this weekend, where we're going to be doing some major maintenance and physical relocation of some of the equipment that's in our data centers. And so the PDA suite, just the PDA suite, not all of RITIS, will be offline from 9 a.m. Saturday morning until 6 p.m. Monday. So, hopefully we can make it a little bit less than that, but that's the full maintenance window. And just after that, some of the more recent probe data might be available until 6 p.m. Thursday, as things continue to catch up and all the data gets backfilled. So it's going to be one of our longer maintenance windows, but it's going to lead to much higher reliability moving forward. Next slide. And that's it. Now I'm going to turn it over to Denise.
Thanks, Michael. Good stuff. Wow. Always impresses me every time I see this. So thanks. I am actually standing in for Matt Glasser today, who has been spearheading this initiative called the British Product Enhancement Working Group. And so I'm here just to provide an update to y'all. Next slide, please. So for those of you that are not aware of the working group, basically discussion has been how could we form something like a nimble pooled fund, something that would allow states to add funding into, whether it's their MOU agreements or direct funding lines to fund RITIS enhancements and help prioritize some of the efforts that the CATT lab is doing. So this is how the genesis of how this discussion started. Also, looking forward, it may be a way to provide some sort of stable annualized funding and to really connect the agencies that have similar needs. So that's kind of how the discussion started. Next slide, please. So in the timeline of when this started, it actually started last summer, where Michael did a presentation on all of the possible enhancements or requests that he'd gotten over the years. And it's really a rapid fire type of user group voting and a prioritization of what was important. He then came back in the fall with a presentation of the voting results at the user group meeting. And then in the winter meeting, we decided to let's form a RITIS enhancement group. It was a smaller group, so it's not as the large user group today you have, but it was a smaller group of interested members in terms of how could we move forward in terms of looking at these enhancements. In the spring, we did a presentation of the initial estimates, and you'll get to that in a moment, in April, and then a determination of enhancements in May. So those slides will follow, but this is where we are right now between spring and future in terms of what are the prioritized enhancements we want, how do we fund them, and moving forward. Next slide, please. So back in April, Michael presented, these are the summary of what was called highly requested enhancements. There's 24 of them, starting with number 1 being the customizable causes of congestion pie chart. So that's more of that deep dive analytics that Franz noted in his presentation. And then as you can work your way down them, ways enhancements, speed tile layer options. These were all the top 24 that came out of that prioritization process that we had done. And initially so next slide, please. So then within, I'm sorry, Joanna, can you back up for just a second to that slide? Back up. Michael then asked at a meeting in April if we could simply prioritize out of these 24, what would be the most important. So we came up with so we're kind of honing down into the top 12. So next slide, please. So these are the top 12 ranked enhancements by group. This was done in May. The original prioritization was in April. We came back in May to a smaller working group, and these are the top 12. Obviously, the congestion pie chart came up as number 1, ways enhancements, and these are the top 12 prioritization for those states that might have funding. So next slide, please. So where does this all leave us? Okay, the idea behind this had a twofold initiative. One was some states currently have funding that could lapse at the end of the fiscal year. So there's been an ongoing initiative to talk about what would be available for now, and then moving forward, how do we annualize this and how do we make it part of the RITIS process in terms of enhancements? So the poll results were shared. We shared them with the working members. We've kind of approached the agencies that have funds available for this fiscal year and looked at enhancements that could be a priority. They looked at money. They've placed votes, or they're placing votes by May 14th. So we've got a 5 bulleted kind of prioritized items to do for this year. And then looking at moving forward, what can we do? We're going to provide an update, I think, at the next July meeting in terms of what's going to be done versus what's going to be moving forward. And the working group, the actual working group itself, is going to meet in October, twice a year. So again, I think from all of that, core summary to take away is that there are some prioritized bulleted items that we're looking at now to grab money from this fiscal year. Moving forward, we're going to see if we can eventually get into some sort of annualized cycle to be able to bring this funding into some of the member agencies' agreements and task orders. Michael, did I miss anything? We defer to you.
I don't think so.
All right, next slide, please. All righty, moving forward, I'm going to turn this over to John Allen, and he's going to talk about the performance measures working group that he manages.
Great.
Anyway, John.
You. Can you hear me okay? Okay. So I want to just give folks a quick update on some of the work we've been doing with the working group and at the CATT lab as well to crank out some of these performance measures templates. Next slide. So here's today's topics. First, I'm going to touch on what we're doing with the RITIS templates page, which is where all these templates will be available. Then talk about some of the one-pager options that we developed with the working group and then fine-tuned it later on for before and after studies, as well as after action reviews. Talk about a little bit of the test drives that some of the member working group agencies have been doing, using some of this templates in real-world conditions. And then finally, we're going to talk about a TSMO quarterly tracking template that was done for a member agency at a special request. Next slide. Next slide. So this is the latest version of a mock-up of the RITIS templates page that we're going to be developing. This is probably pretty close to what it's going to look like eventually. So all you would do is click on the templates link up at the top. You'd open this page and there would be different buttons for you to click on depending on what template you were interested in. So let's just say you wanted to click on the quarter performance report one. Next slide. So then you would get up with this page, which would basically give you some access buttons to download the template or some other design resources like the design sheets we have. Then there'd be some listings of sample templates that other agencies have used for their own purposes. So you can click on that and look at them and see how they use this particular template for their use. And as you scroll down, you'll see information about what tools we're using in the report, some basic design recommendations to keep in mind as you're developing your own report, and then finally how to create the report step by step. So in this example, there'd be information about how to create the front and back covers, project summary, and some of the results from using the RITIS tools and putting it into this report format. Next slide. Next slide. So we talked a little bit about the different one-page options for the reports, and everybody felt that that was a good thing, especially if you wanted to share for non-technical groups. For example, your upper management or senior leadership, the media, whomever. This was a first attempt using an after-action review, pretty detailed report and putting it into this format, but it was still very highly technical, mainly used for staff, and we wanted to take this to the next level, simplify it, and make it more usable for the non-tech types. Next slide. So here's a series of slides that we came up with. Again, it's the best for folks like your senior leadership, your management, legislators, and those people because it's cleaner, it's not as busy, it's easily understood, simpler groupings of information and pictures, and it's soundbite kinds of summary text that legislators and the media love. So it'd be very easy for them to look at this and get a real sense of what happened. Next slide. This is another option where you can add an incident timeline into the graphic, and very simple icons. You can move everything around. I just wanted to mention again that all these templates were created in PowerPoint and they're fully editable. So when you get a hold of these things, you can do whatever you want to do, change things around, resize colors, shapes, anything you want to make it more applicable to what you're trying to convey. Next slide. And this is more of an infographic style. So there's a little more emphasis on the areas of impact for this particular incident and a little less event timeline information, but there is some information still there about that. Next slide. And this is a possible flip side. If you wanted to add some more detail, depending on your audience, you can pull some things from RITIS directly. And here we show a screenshot of some of the secondary incidents that were occurring in the area because of this, basically a bridge closure because of a big truck rammed into some other work trucks and closed the northbound 495 loop for 10 hours. There's a comparison to user delay costs from that day versus the shoulder days of Wednesday that were similar. There's a travel time index comparison of alternate routes that occurred throughout the day. You can just see how much the event impacted those routes. And then the extent of the actual incident. Normally by 8 o'clock in the evening, everything would be clear basically around the Beltway, but in this case, there's still some significant regional congestion because of the extent of the accident. Next slide. We moved on to a one-pager for before and after project assessment. This was done for GDOT. What they did was do a traffic signal timing operational improvement. We took some of their work that they'd done, which was really great. I think I've shared this with you before, and just repurpose it and reimagine it into other single sheets that might work for you. So in this example here, we have a quick summary of what the project was, and then some basic icons and summary graphics of some of the more important improvements that occurred because of the project, and up in the upper right-hand corner, some key project route aspects. Next slide. And this is just the same information, basically reimagined a little bit, but we added a project location map to it so you could see the number of intersections and their locations, little blurb about what the area is comprised of. It's a mix of commercial and residential, the endpoints as the project, and a key intersection there that was a major bottleneck that has been improved from the project. Next slide. And here's some portrait alternatives for that same information, just to give some folks choices about what they'd like to present and how they'd like to present it. And I always tell my grandkids, life is about choices. So I wanted to give you as many choices as possible to be able to take your data and your results and fit it into a way that conveys the message to your audiences the best possible. And there's a flip side on the far right of you could put something in the back with additional information. It's really up to you what you can include there, but it's kind of laid out in a way that should be very easy for you to put the information in. Next slide. Okay, next slide. These are the template test drives that we had some of our working group member agencies to do. The first one was doing a quarter performance report for US 40 by MW Cog in the Washington area. So they used obviously a number of different report and results from RITIS and PDA suite to put together the report. And the one highlighted there in the gold box was a page from the quarter performance report that they added to the report. Next slide. And here, GDOT had a consultant who was working on a concrete rehab project on I-75, used the before and after project assessment to do their project assessment report. So they did that. This is really something that's ongoing and was going to evaluate lane closures that were occurring during the project. So it's an ongoing thing. It's really a before and during report, but they found it to be very beneficial for telling the story about the impacts of this construction project. Next slide. Now, Matt Glasser from GDOT had provided me with some slides about a incident that occurred on I-75. It was a pedestrian hit and run. And I used that and put it into one of the basic templates that I showed before. So this is how it laid out. There was an incident timeline there from when the pedestrian was struck till when the road returns to normal flow. A little incident location map, a description of what happened, some specific detail to the timeline, and traffic impact in a general sense to the area, and a little picture of the extent you can see of the road closure there. Next slide. We wanted to give some alternatives to that particular template. So Matt had also provided 2 additional timeline styles, and we like this one in particular. And it blends not only what happened during the event, but also captures the speed changes throughout that timeline. So I think it's very effective in conveying, okay, things were good, things closed down and opened back up. So it just gives a better sense of the changes of the speeds and the activities out there during this particular event. Next slide. And this is a traffic incident management style timeline that Matt also had provided, and we just added it in here with a typical timeline detail that you would see with a TIM timeline. Next slide. And if you want to supplement that with additional information, you could do that on the flip side or another page. So in here, for example, we added some performance chart information from looking at the year versus that particular incident. You could see that Monday, December 9th versus the 2 shoulder Mondays, how different the traffic was. We added some call outs to help people understand exactly what happened there. And in the bottom right, there's some incident information from GDOT that shows some secondary incidents that happen in the black dots. And you can see there's a cluster there at the end of the queue. Next slide. And Tom talked about his quarter performance report he did for I-76. Next slide. Okay, so an agency came to me and asked if they could have me develop a quarterly report using some of the information they provided me for a TISMO reporting. So I did that, and here's these 2 options. One is a more standard or traditional kind of style, and one's more infographic style. They like them both. I anonymized them, so these numbers aren't really real, and there's no XY State Department of Transportation, but this gives you another option for looking at information and putting it in a form that may be easy to read and easy to convey to your different audiences, especially senior leadership who like both styles, and there was a split there about that. So it's good to have different choices and see which one works best for you and your audiences. Next slide. So right now, these are the different templates that we have available in these particular categories, and we're working on others to add to, for example, a top 10 bottleneck template. And you can see there's a choice here of full technical reports and one-pagers, in which within each category, there's choices too of different options for layouts or information. So it's even more than this, but these are the kinds of things that will be added to the RITIS template page eventually. And we're looking to do that deploy of that page probably by the end of this summer. Next slide. And that's it. Any questions or comments? Okay, I guess I'll turn it back to Jesse.
Thanks, John. If anyone has any questions for John, feel free to use the raise hand feature or, type into the Q&A box. So we have a few minutes left here. I think most of our questions have been answered, but if there's anything else for the agency input session, we could get into that now. I see a couple new questions appearing. One from Russell Holt here. So all RITIS users will have access to at least the templates by the end of summer. Is that correct, John? I see you're typing an answer already.
Yes, that's true. By the end of the summer, probably, most likely. It's a priority for us to get these in the hands of folks. I think it'll really help save a lot of time and effort.
Yeah,
And money.
absolutely.
If anyone desperately needs some of these templates ahead of time, we can probably get them to you. It's the framework around the templates that has all the instructions and everything else. That's what's taking a while to get put up on the RITIS website.
Thanks, Michael. Good to know. So if anybody's working on something and you want to test drive one of these templates, reach out to John, reach out to the team here. Looks like another question for you, John, that you're answering about the number of responders on the bridge incident and where those numbers came from.
Right. So that information was provided by MATOC, who manages a region down in the Washington, Virginia, Maryland area. So they provided that. I'm not sure exactly where it came from. It was either something that they had been plugged into, or it may have come through RITIS, because the incident management tool is very good and comprehensive. So I can find out exactly, Alvin, and get back to you on that.
Is there anything else from any of the kind of prior questions that anybody wants to elaborate on? I think everyone did a great job of answering all those in the chat. I guess the one I wanted to maybe bring up was Enoch's question about the API feature, because I do think that's a really powerful feature for those who sort of know how to use it. So Michael, I don't know if there's anything more you want to say about that. I saw you had answered his question, but.
Sorry, which one was this?
The question about APIs and who can get access to that.
Oh, yeah. If you're interested in the API, just send an email to support@ritis.org. There's a whole process we go through to get people onboarded with the API. And that's really meant for people who want to do their own software development, their own application development.
Yeah, not for everybody, right? But for those who want to use something like that, definitely a very powerful tool. And it looks like John is answering the last question here from Ira about the truck crash.
Yeah, let me just say that what happened was it crashed on the northbound outer loop of I-495. And so because it was such a horrendous crash, involved fatalities and a fire, they had to close down those lanes for over 10 hours. So the entire northbound lanes on the bridge were closed down for that long a time.
Wow. Yeah, that's quite an incident. Thanks everybody for all the great questions. Definitely a lot of good questions in the chat. Obviously a lot of interest in the congestion pie chart, and also just some of the methods of doing some of the technical analysis that Tom had walked through. I guess I was curious too if other folks have done any similar kind of type of analysis looking at changes in congestion during the pandemic. We certainly in the Philadelphia region, as Tom showed, have seen a lot of change. It really varies by facility. So I think we're just about out of time here, but if anybody has done similar analysis, certainly feel free to reach out to the team here and share what you've done, and potentially could be another presentation in the future. Anything else, Joanna, as we kind of close out for the day here?
No, just we'll probably keep the Q&A open for another 5 minutes or so. So if there's something that you didn't get to ask and you want to put it in there, please do so. Of course, you can always reach out to our speakers. But we will make sure anything that gets into the Q&A does get answered by the speakers for the Q&A summary that we prepare.
Also,
Michael, you have something.
the Q&A shouldn't just be for questions. If you've got complaints or requests, things you wish the tools did but don't, or a frustration that you've got, please let us know. That things only get better if you let us know. So put something in the Q&A box for us, please.
With that, I guess I'll thank everybody for attending today. Thanks to all of our great presenters. Thanks for all the feedback we got in the pod there. And again, we will keep it open for a few minutes. So, you just got an open invitation from Michael to tell him what else to work on. He's already got a long list, but he's asking you to add to it. So feel free to do that. And once again, thanks everybody for joining us and participating today.
Thank you, Jesse.